Opportunity to celebrate scientists who are making a positive impact on our world. Today, you will have the pleasure of hearing from the remarkable researchers who were announced as the 2021 OWSD Elsevier Foundation Award for Early Career Women Scientists in the fields of physical sciences, chemistry, mathematics, and physics. AAAS greatly values the strength that diverse voices bring to the scientific endeavor and strives to enlarge that discourse every day.
AAAS has many initiatives that are looking to even the playing field for women and minorities in science, technology, engineering, math, and medicine, or STEM professionals. Just to name a few, we have the Sea Change program, a comprehensive initiative guiding U.S. institutions through self-assessments to effect sustainable change with regard to diversity, equity, and inclusion. We're working to make DEI normative in academia, industry, and government. The AAAS HBCU Making and Innovation Showcase, which has been renewed for another 3 years, brings 80 students and faculty from historically Black colleges and universities, HBCUs, for 2 days of workshops and training on invention and entrepreneurship. The Emerging Researchers National Conference brings approximately 1,000 undergraduate and graduate students from underrepresented communities to Washington, D.C. to share their research and develop their careers.
AAAS has also had the privilege of administering the awards honoring the achievements of women scientists. In November, we announced the 2020 L'Oreal Women in Science Award winners, who are awarded a grant to advance important postdoctoral research in fields as diverse as neurobiology, metabolic diseases, physics and material science, integrative biology, and biomedical engineering. Additionally, in December of last year, we announced the 2021 Marion Milligan Mason Award for Women in Chemical Sciences, which is designed to kickstart the research career of promising future women senior investigators in the chemical sciences. And of course, the reason why we are here today, to host the Women and Minority Awards. I'd particularly like to thank our sponsor, Johnson & Johnson, for supporting this event. This year's event looks very different from years past. However, I'm grateful that with Johnson & Johnson's support, we're still able to continue on in this virtual setting. And the J&J representative here today is Sema Kumar, who you will have the opportunity to hear from in a moment. Again, we want to send our heartfelt congratulations to the winners of the 2021 OWSD Elsevier Foundation Award for Early Career Women Scientists. These women are outstanding researchers in the chemistry, mathematics, and physics fields, and I look forward to listening to each of their inspiring stories. After this award presentation, we invite you to meet and talk with the winners in the Women and Minority Scientist and Engineering Awards roundtable discussions. Please look at the conference schedule for the time and the link. So without further delay, I would like to introduce Johnson & Johnson's Sema Kumar.
I'm so thrilled to be here today, even if virtually, and to join you in championing the inclusion of women and minorities in science. This is a topic that has reached a new level of urgency in the past year, but I believe it has also reached a new breakthrough potential. Our world is facing one of its greatest healthcare challenges in COVID-19, and in the US, we're also facing up to a new truth. The COVID-19 pandemic has opened our eyes to another pandemic that has plagued us for centuries in the form of systemic racism and health inequities. But the good news is companies, public officials, and private citizens are taking action and beginning to address health inequities, in part through greater inclusion of women and of minorities in the STEM and healthcare ecosystems. We need culturally competent community solutions, and we need diversity among healthcare providers to create healthier outcomes, especially for communities of color and people living in under-resourced communities around the world. We need diversity of thought, the very best ideas from wherever they can be found to generate new innovation that can restore our world to good health and normalcy, including new therapies and vaccines like those that Johnson & Johnson is working on. And globally, it's critical to ensure equitable access to these innovations. Women and minorities everywhere should also have access to education, science, and technologies that impact their daily lives and their families. We also have to build trust and ensure diversity in clinical trials to ensure that new solutions like vaccines meet diverse needs and addresses diverse biologies. Vaccines that work well for everyone are important to individual health. And at Johnson & Johnson, we recently launched a $100 million commitment to help advance racial and social justice by eliminating health inequities for people of color. A big part of that program is our ongoing effort since 1908, when we first hired our first woman scientist, to cultivating a diverse and inclusive workforce that inspires innovative healthcare solutions all over the world. We have a new goal of achieving 50% growth of Black talent at the manager and above levels in the US over the next 5 years. We're also continuing to invest in women in STEM through our We STEM 2D program and through important convening opportunities like this one with AAAS. And we're continuing to tell the stories of women and minorities in science, your stories, through our Champions of Science program and storytelling challenges, and through our Road to a Vaccine live broadcast series on LinkedIn, focused on demystifying vaccine technologies and showcasing the people all over the world, the doctors, nurses, researchers, epidemiologists, and advocates who are working to end this pandemic and save lives. We're kicking off our next season soon. Please enjoy your breakfast and your coffee and the thought-provoking and important conversations and stories we'll share here today. I'm really looking forward to it, and thank you.
It's an honor to join you virtually during AAAS to celebrate the achievements of 5 very impressive scientists as part of the Elsevier Foundation Awards for Early Career Women Scientists in Developing Countries, in partnership with the Organization for Women in Science for the Developing World. My name is Kumsal Bayezid, and I am the CEO of Elsevier, the information analytics company, which most of you will know as one of the largest publishers of quality scientific research. I am proud to serve as the first female CEO in our 140-year history and to support this important program as a member of the Elsevier Foundation Board. At Elsevier, we believe that the research community shapes the future. A woman must be an equal part of that conversation. And it's not just about women. People of different races, ages, backgrounds, sexual orientation, and ability belong in the conversations that shape everyone's future. This is why we have a deep commitment to advancing inclusion and diversity within our own company and in the communities that we serve. We want to serve to harness the full potential of every talented researcher, whoever they are and wherever they come from. Representation and participation of women in science has been a key goal for the Elsevier Foundation for more than 15 years. Today's awards are part of this endeavor. Together with the Organization for Women in Science for the Developing World, we want to increase the visibility of outstanding women scientists who are doing impactful research, often in challenging or research-constrained circumstances. In doing so, we hope to create opportunities for collaboration and career advancement, and to inspire future generations of women scientists in developing countries to follow in their footsteps. Since 2013, we have celebrated 40 women scientists from 19 countries at the AAAS who are making life-changing contributions to society through their research and helping to advance the UN Sustainable Development Goals. Let me share a wonderful example with you. In 2019, we celebrated Dr. Narelle Zambrana, an ethnobotanist from Bolivia, who worked with indigenous communities to raise awareness of their use of native plants and contribute the knowledge to science. When she returned from receiving her award at the AAAS, she was invited by the President of Bolivia to share her research in a face-to-face meeting. The World Food Programme in Bolivia then established a joint project using traditional knowledge for food security. On International Women's Day, they painted a mural of Narelle at work. The message: every girl can be a scientist if she wants. We are truly proud to celebrate your accomplishments, Marion Nakancha, Imalka Munavira, Gada Dushak, Maria Catalan, and Concursul Dorjgotov, together with the OWSD at the AAAS, a conference and community where scientific achievement meets policy and innovation. So on behalf of both the Elsevier Foundation and Elsevier, a warm congratulations to you from all of us.
My name is Jennifer Thompson. I'm the president of OAS, the Organization for Women in Science for the Developing World, and I'm here to introduce you to this year's winners of the annual OAS Elsevier Foundation Awards. And they are a remarkable bunch of women and come from very interesting countries. The first, and there's no particular order, is Gada Dushak from Palestine. She's a physicist and currently a postdoc at New York University, but she's a multidisciplinary scientist working both with and in materials engineering, electrical engineering, and physics. This allows her to have a rather different perspective, and her aim is to produce new materials for many different devices, both in the home and at work. Then from Mongolia is Kongar Zul Dorjgotov, and she's a mathematician. And she lives in a country that is probably the most sparsely populated in the world and is certainly her capital is the coldest in the world. Many of the people there are nomads. And this is remarkable that she has become this very, very accomplished mathematician using fractional differential equations to help her to solve biological problems. Then comes Marion Nakancha from Ghana. She's a chemist looking at environmental problems to solve using her knowledge, particularly in industrial pollution of water, to improve the lives of the people in Ghana, particularly in heavy metal pollution. And she looks at it in many different areas, physical areas like children's playgrounds. Then there is Catalan Cabrera from Guatemala. She is a physicist, and she is looking to understand dark matter, to unravel the building blocks of nature. She also has developed a network of women scientists in her region of Latin America, which thrills us no end. And finally, and not at last, Imalka Munawira. She is from Sri Lanka and is a material scientist. She's using nanoparticles to produce things like cost-effective fertilizers and, amazingly as well, cancer therapy. And she has patented a number of her findings, and they are also getting into commercialization. And this is despite the lack of chemicals in her country and limited resources for her research. So I think you will agree with me that this group of 5 women scientists from all over the world are truly remarkable. And I hope you will enjoy their speeches in giving you an outline of their own research endeavors and successes. Thank you.
Today we are celebrating 5 women scientists from Guatemala, Mongolia, Palestine, Ghana, and Sri Lanka. My name is Ilan Shem. I'm the director of the Elsevier Foundation, and we are honored to join the AAAS to mark the 2021 OWSD Elsevier Foundation Awards for Early Career Women Scientists in Developing Countries. You will hear their stories directly from them in just a few moments, but first let me tell you about how, together with the Organization for Women in Science for the Developing World, we have built these critical awards over the past 8 years. Both OWSD and the Elsevier Foundation know from experience and past programming that women scientists in resource-constrained environments often experience isolation, a lack of visibility, a lack of role models, you name it. Our goal with these awards is to create that visibility and new opportunities through a special awards program which rotates each year between the biological sciences, the physical sciences, and engineering, innovation, and technology. What I'd like to highlight is that the AAAS is also a critical supporter in this endeavor. They've helped us for the past 8 years to really put a spotlight on the work of these impressive women scientists by enabling us to celebrate at the Gender and Minority Networking Breakfast. So in addition to our $5,000 prize, our winners traditionally come to the AAAS conference. They experience the incredible networks, the scientific dialogue, the groundbreaking science. It's all incredibly exciting and useful. We have found that it has opened many doors. It has forged new partnerships, new international networks for them, and often they come away with opportunities for fellowships or additional awards, collaborations. It's really an incredible space for them to be. Now, although the pandemic prevents us all from coming together in person this year, we are still so grateful for the chance to celebrate their achievements virtually and together with all of you at the AAAS Gender and Minority Networking Breakfast. So before you hear from our 5 incredibly talented winners, I would like to also welcome perspectives from Dr. Jennifer Thompson, the president of the Organization for Women in Science for the Developing World, and Kumsal Bayazit, the CEO of Elsevier and a member of the Elsevier Foundation Board. Thank you so much.
Hello everyone, my name is Ghada Dusha. I'm a Palestinian scientist working as a postdoctoral researcher in the Photonic Research Lab at the New York University, Abu Dhabi campus. My research is in optoelectronics and photonics. This research field is kind of multidisciplinary, which spans material engineering, electrical engineering, and also physics. In particular, my work focuses on developing a new material, such as germanium-based 2D materials and novel structures that can boost the current performance of optoelectronic devices. What I love the most about my research, given the fact it is multidisciplinary research, allows you to interact with researchers from different backgrounds, and this actually gives you the opportunity to grow and also to look on things from different perspectives. Ever since I was a child, I loved science, and I got a great excitement to be in any lab environment. And also the curiosity about how nature works and what are these materials made of motivates me to be in a research and in science position. Also the tremendous support I got from my family and my mentors all the way to the PhD level support me and motivate me to pursue my career in science. As an Arab woman in science, I haven't experienced explicit form of racism or sexism. I am very aware that we are a minority. There are not many girls as a faculty position or research position, but in my case, I think it gives a sort of positive discriminatory trait to actually stand out and to achieve even more, to prove to myself first and to the society that we are capable and actually we can change and shape the future. Thank you.
Greetings, my name is Marion Nakancha. I am an associate professor of chemistry at the Kwame Nkrumah University of Science and Technology in Kumasi, Ghana. I am a daughter of 2 educationists, and therefore going to school was not an option but a matter of necessity. I grew up in the early 80s in Ghana, where the economy was in bad shape, and therefore had to learn very early gratitude for the things I have, concern for those who don't have, and the need to give back to society. This quest, coupled with my curiosity, is what will lead me to do science in the secondary school and then chemistry in the graduate studies.
Hello everyone, I'm Dr. Malka Munamira and currently I'm a senior lecturer at the University of Sri Javadharpur in Sri Lanka. My main research field is nanotechnology. Nanotechnology is science, engineering and technology conducted at nanoscale, which is about 1 to 100 nanometers. And the materials made at nanoscale will give them enhanced properties and we can use them in various applications. I was able to develop magnetic nanoparticles during my undergraduate research by applying theoretical concepts to practical problems. The research I did for my Master of Philosophy research degree resulted in 2 US granted patents for developing an environmentally friendly, slow and sustained release fertilizer formulations using nanotechnology. And these patents were commercialized. It is a national and international interest to develop and manufacture a cost-effective fertilizer which addresses the major issues in common fertilizers. I received the National Science and Technology Award in year 2010 for this invention. Then I moved to United States to do my PhD at the University of Texas at Dallas and refined my career path into cancer therapy and drug delivery, a specialty of lung and skin cancer research that has linked with one of the most critical public cancer issues in the world. I found an innovative approach that could reduce tumor burden in patients. My novel chemoradiotherapeutic formulations and radiotherapeutic bandages were recognized by the American Chemical Society and Fiber Society in USA and selected as one of the best researchers. I obtained another 2 US granted patent for this research by contributing to the advancement of world healthcare needs. After spending 3 years as a postdoctoral researcher at UT Southwestern Medical School in USA, I joined Texas Prairie View A&M University in United States as an assistant professor. Being a woman and a responsible mother, I had a lot of family commitment during this time and I decided to return back to Sri Lanka in year 2019 with my family. I had many unforgettable barriers as a woman during early stage in my career. My father was a cancer patient and I was not at a good position. Somehow I was able to manage all my difficulties and perform well in my undergraduate studies. As a developing country, we had very limited resources at university and we didn't have enough chemicals at research laboratories to explore things that we really wanted. We live in technological world and we have so many challenges in front of us. Sometimes the discovery in the laboratory can lead to new product that will be useful to entire world. So my passion is to make exciting discoveries and help to solve huge global problems and I strongly believe that my passion brought me to this level to receive this prestigious award. Thank you.
I am Maria Eugenia Cabrera Catalán. I was born and grew up in Guatemala. Currently, I am professor at the University of San Carlos of Guatemala, USAC, where I got the degree in physics. When I was a student, there were no postgraduate programs in physics in Guatemala, so I decided to go abroad to continue my studies. I felt extremely curious and captive about understanding how nature works at subatomic scales. I was accepted to the High Energy Physics Diploma program in the International Center for Theoretical Physics Abdus Salam in Trieste, Italy. This program gave me the opportunity to apply to a PhD program in prestigious universities. I did a PhD in physics at Autónoma University of Madrid. And after that, I did the first postdoc in the Grappa Institute of the University of Amsterdam and a second one in the Physics Institute of the University of Sao Paulo. While I was in Sao Paulo, USAC approved for the first time the opening of a call for permanent position in physics and mathematics, with 75% of the time dedicated to research. This was a great opportunity. So I quit the postdoc and came back to Guatemala. During all these years, my research has been focused on understanding how nature works at subatomic scales. Our knowledge of physics at very small scales or equivalently at high energies help us to understand the history of our universe. There are some experimental measurements that we cannot explain. For example, astronomical observations tell us that the most abundant matter component of our universe is dark, meaning that it doesn't emit or absorb light, and it is only known by its gravitational interaction. None of the fundamental particles that we know have the correct properties to be this dark matter. So my research focus on describing the interaction and range of masses of potential new particles that are part of well-motivated scenarios of a more fundamental theory, which could explain the nature of dark matter. Describing this interaction for massive and weakly coupled dark matter particles have allowed us to describe the type of signature that could be expected in different kinds of experiments. This research is very exciting, among other things because it represents the possibility of being part of a worldwide effort to understand the building blocks of nature as Guatemalan scientists. Also, because I am the first Guatemalan woman graduated in physics in Guatemala to get a PhD in physics, and until a few months ago, I was the only woman with a PhD in my institute. At a regional level, together with some colleagues from Honduras and Guatemala, we have organized the first Central American meeting of high-energy physics, cosmology, and high-energy astrophysics. As a result, it was agreed to form a Central American network of high-energy physics and scientific computing. Thanks.
Hello everyone, my name is Hongarzul. I am from Mongolia. Mongolia is a landlocked country between Russia and China. It has over 3 million people and is considered the 18th largest country of the world. So Mongolia is the most sparsely populated country. The capital is called Ulaanbaatar and it is the coldest capital in the world. Traditionally, Mongolia is a land of nomads. Now almost half of the Mongolians still live as nomadic herders, just like hundreds of years ago. It's quite a unique lifestyle. Just imagine that a nomad family packs all belongings, including their home, and moves for hundreds of kilometers, at least 4 times a year, to find a suitable pasture for their livestock. For me, herding 100 sheep at this step was harder than teaching calculus to 100 students. All are welcome to our land of blue sky, when everything gets better again. As for myself, since I was a child, I really liked puzzles, secrets, and mysterious things, and my childhood dream was to become a detective. But somehow I ended up becoming a mathematician. But in my view, I think that studying mathematics is as mysterious and adventurous as being a detective. I got my bachelor's and master's degree at National University of Mongolia, the oldest and state-owned university of Mongolia. There I was studying numerical analysis. Then I got Japanese government scholarship for a doctoral study at Kyushu University. At Kyushu University, I started doing research on fractional differential equations, an emerging branch of mathematics, focusing on Lie theory and symmetry approach to differential equations. We know that the differential equations contain derivatives of order of natural numbers, but the fractional differential equations contain derivatives of order of real numbers, like derivative of order 1/2. Before I explain what we obtain, I will explain briefly the classic results. Euler was the first to solve the linear ordinary differential equations with constant coefficients by using the solutions of characteristic equations. So we are interested in whether there exists an analogous method for fractional differential equations. And I, with my colleagues, developed a method similar to Euler's method for solving a class of Euler-like fractional ODEs. We found analytic solutions to the certain type of fractional differential equations by using solutions of characteristic-like polynomials of the equations considered. Then we also reduced the fractional diffusion wave equations into fractional ODEs of Eulerian type by using Lie symmetry approach. In other words, in a sense, we gave solutions to models of complex systems, such as diffusion of crowded liquids inside biological cells, or diffusion of solutions of polymeric materials. And the photocopier at your office rely on transport of electrons at amorphous semiconductors, and this process is expressed mathematically by fractional diffusion wave equations. Now, in addition to working as a senior lecturer and a member of Center of Mathematics for Applications at National University of Mongolia, I am trying to increase the collaboration between industrial and academic sector in Mongolia. To do so, I, with fellow researchers, organized study group workshops with industry for the first time in our country. It is an internationally recognized method of technology and knowledge transfer between mathematicians and industrial sectors. Thank you for your attention. It was my pleasure to introduce my country and research to all of you. Wish you all the best.
I'd like to offer my warm congratulations to these awardees and our partners who help make this possible. Thank you so much for joining us. Hello, I'm Sudip Parikh, and I have the privilege of serving as the CEO of AAAS.
Greetings. I'm Claire Fraser, the president of AAAS. We'd like to welcome all of our virtual guests to the 2021 Minority and Women Scientists and Engineers Awards.